All right, so today we start talking about how do we solve triangles? How do we find missing pieces of triangles that are not right triangles? So the first thing I want you to do is label these three sides. So yours should look like this, where I got angle A, angle B, and angle C. The side opposite angle A, so that's a big A, we're going to put a lowercase a. The side opposite angle C, we're going to put a lowercase c, and the side opposite angle B, just put a lowercase b. So this side length we're now calling C, this side length we're now calling A, and this side length we're now calling B. Okay, so the law of sines says that I can do this, that this is allowed. I can take the sine of angle A, put it over the length of side A, and it should be proportional to the sine of angle B over the length of side B, and the sine of angle C over the length of side C. So this right here is called the law of sines. This one you will have to memorize. You will not have this on any formula chart that we will use. You just have to have this one memorized. Okay, so now when do you want to use the law of sines? You want to use the law of sines when you've got triangles arranged in this fashion. When I've got angle, side, angle, 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 side, or side, side, angle. So just write that down. That will hopefully make more sense here in a little bit. Okay, so now we're going to use the law of sines and we're going to answer the question. So let's look at A. Okay, so I've got my A. Here I've got this one is 4 feet. I know this one is 15 feet. This is 102 degrees. And I want this angle. So what information am I given? And in what order is it given to me? It looks to me like I have a side, I have another side, and then I've got an angle following that. So it looks to me like it's side, side, angle. And so that's one of the ones right here that's telling me that I should be using law of sines. Okay, so I want this piece. So it looks to me that I can take the sine of this piece, the sine of x, and put that over 4. So the sine of x over 4 equals the sine of 102 over 15. So that's where this proportion comes from. So the sine of x over 4 equals the sine of 102 over 15. So we just have that little proportion there. So now I cross multiply, and I then get 15 times the sine of x equals 4 times the sine of 102. That's where this comes from. Now I'm going to divide both sides by 15, and then I get this, which provides me that the sine of x is now equal to 4 times the sine of 102 divided by 15. Again, all I did to go from here to here was I divided both sides by 15. So now these 15s will cancel out, so all I have left over here is sine x, and on the right hand side I have 4 sine 102 divided by 15. So now I have the sine x equals 4 sine 102 divided by 15. I can put this whole mess into the calculator. 4 sine 102 divided by 15. It'll give you an ugly, ugly decimal. Then that's the sine of x. So to get the angle measure, I'll then just hit inverse sine, and I'll get that my angle is 15.1 degrees. Okay, so let's do another one. So this one I've got this picture. Okay, so I know this side, I know this angle, I know this angle. I didn't have that angle, but I know what it is. If I know two angles, I can get the third. That's got to be 78. So basically what was given to me, what was provided, was I had an angle, I then had a side, and then I had an angle. So that matches with this angle, side, angle that I gave you earlier. So if I'm provided angle, side, angle, again, I'm going to use the law of sines. So I take the sine of 62, the sine of 62, and I put it over the opposite side. So sine 62 over x equals the sine of 78 over 12. So sine 62 over the opposite side, which is x, equals sine 78 over the opposite side, which is 12. So now we just have a little equation. We're going to cross multiply. So I'll get 12 sine 62 equals x times sine 78. Now what's on the same side as my letter? Just sine 78. So I divide both sides by sine 78. and I get x equals 12 sine 62 divided by sine 78. At this point, I can put that whole mess into the calculator just the way it is, and I'll get that my answer is 10.8. That's what I was trying to find. Okay, so that's the law of sines. I've got more examples on the back of the sheet, and we'll do a whole bunch more in class. Okay, law of cosines looks like this. Can I get it all to fit? Yeah, that's going to work. Okay, so again, do what we did a while ago. The side opposite from angle B, put a lowercase b, so it's lowercase b. The side opposite angle C, we're going to call lowercase c, and the side opposite angle A, we're going to call lowercase a. Okay, this is a lot to write down. So now, it starts off sort of looking like Pythagorean theorem. So my first one is a squared equals b squared plus c squared minus 2 times the b and the c. So whatever we're squaring on this side, that's what we're going to multiply right here. And then multiply that by the cosine of the side over here. Okay. And basically what we're saying is that this will work for any order that you want to go in. So a squared equals b squared plus c squared minus 2bc cosine a. Well, then if I want to get the b, I can just do b squared equals a squared plus c squared equals 2 times ac cosine b. And if I want the c, well then c squared equals a squared plus b squared minus 2ab cosine c. This right here is called the law of cosines. And again, you will not have this on any test or any quiz. You have to have these memorized. But if you just look, I mean, this is pretty similar. Just look at that top one and just realize, well, it's a squared equals b squared plus c squared minus 2 times the two numbers that were over here times the cosine of whatever I had over there. And then the other two are just basically variations on that. Again, examples coming in class. When do we use law of cosines? We use law of cosines when I have side angle side and side side side. Okay, so here we go. Here's my first problem. Okay, so I am given a side, I'm given an angle, I'm given another side. That matches right here with side angle side. And I'm trying to find this piece. So if I'm using side, if I'm given side angle side, I want to be using law of cosines. So all I did was plug in right here. Okay, so I have r squared, this piece squared. And how do I know that this one's going to be squared? Because I know this angle. And whatever I take the cosine of, which is over here, remember, whatever I take the cosine of, that other piece, that the side length opposite that angle, that's what's going to go on this side. And that's what I'm trying to find. I want this piece. So what's the angle opposite from that? It's 36. So that's, okay, let's set this up. So r squared, this piece squared, equals the other two sides squared. So 45 squared plus 52 squared minus 2 times the product of those same two sides, 45 and 52, times the cosine of the angle opposite from this side over here, which is 36 degrees. Okay, so now let's try simplifying. So if I do 45 squared plus 52 squared, that's just 4729. Then if I take minus 2 times 45 times 52 times cosine 36 all into the calculator, it gives me 3786.2. So then if I subtract those, I now get r squared equals 942.8. Find the square root, and r is equal to 30.7. Let's do another one. Okay, this one, what am I given? I'm given all three sides. So again, that matches with my SSS up here. So if I'm given all three sides, I should be thinking about using law of cosines. So I come over here. This is the piece that I know which is opposite the angle that I'm looking for. So this needs to be the one that goes by itself, because this is the angle that I'm trying to find, so that must be the cosine that's going to go on the end. So I take 250 squared, this piece squared, equals the other two sides squared. Add it up, 225 squared plus 175 squared, minus 2 times the product of these same two sides, times the cosine of the angle, the opposite side from this piece. And these are going to match up. That's what I'm trying to find, the cosine of x. Okay, so I simplify. This is giving me some big old numbers. 250 squared is 500 squared. That's equal to that, and then I just multiplied 2 times 225 and 175. Gives me all that. Okay, then I just added these two up, gave me that. Then I just subtracted 81,250 from both sides. I subtracted it from here, subtracted it from there, which gives me negative 18,750 on this side, and I'm left with this piece. Divide both sides by negative 78,750 to get this cosine by itself, and it gives me 0.238 equals to cosine x. I get second cosine 0.238. It gives me my angle of 76.2. So as bad as this looks, the majority of this is just algebra 1. This cosine x is like an a or a b, and we're just trying to get it by itself. We're just taking little bitty algebra steps along the way to try to get this cosine x by itself. Okay, 3 problems on the back. So I've got a large helium balloon that is tethered to the ground by 2 taut lines. One line is 100 feet long and makes an 80-degree angle with the ground. The second line makes a 40-degree angle with the ground. How long is the second line? And it says how far apart are the tethers. Okay, so here's my beautiful picture. My helium balloon and my cords. So one is 100 feet long, which is right here, and it makes an 80-degree angle with the ground. So there's that one. The other one, I don't know the length of it, but I know that it makes a 40-degree angle with the ground. And so of course, if that's 80 and that's 40, then that's got to be 60. Okay, so what am I given, and what should I be thinking about? Okay, I know this piece. First, I'm going to try to get this x. I want to get the length of the cord. So I know this piece, and I know my angles. I've got an angle, I've got a side, I've got an angle, angle, side, angle. Law of sines. So I try matching up my pieces. So I take the sine of 40 over 100, sine of 40 over 100, equals the sine of 80 over x, equals the sine of 80 over x. Okay, now let's do some algebra and cross multiply, and we get x sine 40 equals 100 sine 80. Again, these are just numbers. This sine 40 is a number, like 8 or 9. This sine 80 is just a number. We're just trying to get this x by itself. So now we're going to divide both sides by sine 40, and I get x equals 100 sine 80 divided by sine 40. At this point, go to your calculator, put that whole mess into the calculator, and you'll get that x is equal to 153.2 feet. So that is the length of the other tether. Now it says how far apart are the tethers, so we want this y here on the bottom, so we just do law of sines again. I can take sine 60 over y, sine 60 over y, equals sine 40 over 100. So I've got sine 60 over y equals sine 40 over 100. Cross multiply, and I get 100 sine 60 equals y sine 40. How do I get this y by itself? I just divide both sides by sine 40. And now I've got the y by itself, straight into the calculator, and it gives me that y is equal to 134.7 feet. This one. It starts off kind of confusing. It talks about frontages and boundaries, and basically this is all we're saying. I've got a 115-foot frontage over here. Is it feet? Meters. 115 meter frontage over here. I know this piece is 67, this piece is 92, and I just want these two angles. So again, I know all three sides, side, 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 which tell me I got to use law of cosines. So let's try to get this x first. So I take 92 squared, the side opposite from it, because this is the angle that I want, so I got to be putting this side all by itself. So 92 squared equals the other two sides squared and added up, so 115 squared plus 67 squared minus 2 times the product of those two sides times the cosine of x, the angle opposite from the side by itself. Now I just do a whole bunch of simplifying. That's all I'm doing. Simplifying everything. I squared that, put it there, I squared these and added them up, and I just multiplied all these out and got there. Now I'm going to subtract 17714 from both sides, and I now get minus 9,250 equals minus Is that 15,410 cosine x? Trying to get this cosine x by itself, so I divide both sides, and I get 0.6003 is equal to cosine x. So now I hit second cosine, 0.6003, and I get that x is equal to roughly 53 degrees. So now to get the angle y, I just do the same thing. I now want angle y, which means the 67 needs to go by itself. So I do 67 squared equals the other two sides squared and add it up. So 115 squared plus 92 squared minus 2 times the product of the other two sides times the cosine of the angle opposite from this side. Now I just do a whole bunch of simplifying and it takes me to there. Subtract 21,689 from both sides and it takes me to there. Again, trying to get that cosine y by itself, so divide both sides by negative 21,160, and it gives me an ugly decimal. I have 0.8129 is equal to the cosine of y, inverse or second cosine, and I get that y is equal to 36 degrees. Alright, the last one. So to approximate the length of a marsh, a surveyor walks 250 meters east from point A to point B. So he walks from A to B and he goes 250 meters. Then he turns 75 degrees and walks 220 meters towards point C. So there's my triangle, A, B, C. And I want to figure out how far it is from A to C. So what am I given? I'm given side, angle, side. That's what I'm provided in the picture. And if we're talking about side, angle, side, again, that means law of cosines. So I want this side. What's the angle opposite from it? 75 degrees. This is the angle that I know. This is the side opposite. So this needs to be the side that goes all by itself, because this is the angle that I'm using in my problem. So I take x squared equals the other two sides squared and add it up, minus 2 times those same two sides times the cosine of the angle opposite from this side over here, which is 75 degrees. Again, we just do a whole bunch of simplifying over here. All I did was I squared these and added them up, and I just put this whole mess straight into the calculator. Negative 2 times 220 times 250 times cosine 75, and it gives you this number right here. And now I'm just going to subtract those two, and I get x squared equals this big number. And now square root both sides, and I get that x is equal to 291.6 meters. That's all I got for you. We'll do a whole bunch of practice next class.